Alright, good morning and welcome back to Physics of the Universe. Today we'll be doing Unit 19, Part 5 about weather. Today we'll be talking about differential heating and the Earth's surface. Last time I left you guys off looking at this picture that I have in the background here. This is a picture of people out playing with kites. Beaches seem to be a happy place to go out and fly your kites. You can see lots of people out there flying their kites. Well, why is that? What is it about beaches in particularly that they get so much wind? It has to deal with differential heating, and that's what we're going to be talking about today. So let's get going on with that. All right. First of all, there's so many things that control the temperature of the air that we're in, the air that's around us, the air that's lowest in the atmosphere. The first thing we already talked about is solar duration. Solar duration is how much sunlight we get. And remember, that's all based on how the Earth is tilted. If you're in the northern hemisphere, when the Earth is tilted away from the sun, for us, we're going to have short amounts of daylight and long times of night. So, of course, the amount of time that the sun's out is going to help determine how warm the air gets. In the summertime, when we're tilted more towards the sun, we get longer amounts of daylight, and that will determine that we get a little bit warmer. But that's not it. That's not the big thing. The big thing I tried to get across last time was solar intensity, and that is where the sun is hitting you more directly. Another thing that I have alluded to, and we're going to get to a little bit later, is greenhouse gases. How much the atmosphere itself, there's certain gases in the atmosphere itself that can actually take in that radiation from the sun and convert it right to heat. But probably the number one reason that you have really hot days, I should say the number one reason why you have an atmosphere being heated up, the number one thing heating up the atmosphere, is actually the Earth's surface. Our atmosphere, remember, works very much what we talked about last time, like we have with this boiling noodle example right here, where you have conduction, convection, and radiation going on. The radiation would represent the light from the sun, and that radiation's heating up the bottom of the pan. The bottom of the pan is touching the water, and the hot water moves up to the top because it's less dense. The cold water moves to the bottom because it's more dense, and it kind of cycles like that. Well, our atmosphere is kind of the same way. We have radiation coming from the sun. It heats up the surface of the Earth. When it heats up the surface of the Earth takes that radiation. If it doesn't reflect it, it absorbs it. Remember, we called that albedo, the ability to absorb or reflect sunlight. The parts that it absorbs, it is able to turn into thermal heat. That thermal heat is what's actually touching the air. And if it's touching the air, then that's going to cause the air to heat up. So the air around you, the air that's touching the ground, is heating up because of the ground. If you jump into a hot air balloon or an airplane and you start getting further and further and further and further away from the ground, you'll notice that the temperature gets cooler and cooler and cooler because you're getting further away from the thing that's heating up the air. So down by the ground is where it's going to be the hottest. And of course, if it's the hottest by the ground, then that's going to cause that air to rise up. As it rises up, it cools off because it's getting further away from the ground and comes back down. And so what we have is convection, the same thing that was going on with the water inside of your container when you were boiling noodles. It's really kind of the same thing as a lava lamp. I miss my lava lamp because I like talking about a lava lamp a lot at this time of year. The lava lamp basically works like this. You have light, radiation like sun. It's heating up the lava at the bottom. The lava is actually touching a little metal coil that's heated up by that light bulb. And that coil is heating up, is touching the lava, and the lava is acting like air. So this could be very much like air being lifted up because of heat. It becomes less dense. Thus, the cooler air, being more dense, wants to sink down. So once that lava gets to the top, it cools back down. And really, that's what the air is actually doing. The air is actually doing, and in some cases, like blobs in a lava lamp. If you could see the warm air versus the cool air, you might actually see blobs out there. So, let's go to the beach. That's where I really want to go right now instead of being stuck at home. Let's go to the beach. And we've probably all been to the beach before. You probably had the same experience. It's a nice sunny day. You jump out of your car. You forgot your flip-flops. Your feet hit that parking lot or the beach. And then it's like, I know this picture is a little bit weird, but it's like your feet are on fire. I'm sure that's Photoshop. Somebody's foot is not actually on fire. But I did find out, don't go onto the internet and put in burn feet beach, because what you're going to find out is a lot of people do go to the beach, they burn the skin off their feet, and there's lots of Google images of that happening. So be careful with that if you go to burn feet beach. All right, so there's really one thing. You jump out of your car, you forgot your flip-flops. There's really one of three things that you're probably going to do. Number one, you're going to jump back into your car and try to find something to put on your feet, maybe those shoes that you didn't want to wear to the beach, but you forgot your flip-flops, so that's what you're going to have to wear, otherwise you're going to burn your feet. The second thing you're going to do is try to run to the sand, but the sand's still going to be hot. So what do? You dig into the sand and you bury your feet. And as you get just about 3 or 4 inches into the sand's a lot cooler. Or the third thing that you can do is run all the way to the nice cool water. Turns out that this is actually pretty important to weather. What's just happened to you and your feet correlates to really what's going on in the atmosphere. And it's the same idea, believe it or not, that causes big massive rainstorms in tropical places like Florida. So what's happening? When we have parking lots typically are made of what's called blacktop, which is kind of a black tar, just because it's easy to work with, it's inexpensive, and that's why people use it. So we use it a lot. A lot of our roads around here are made of blacktop. And here we've got a thermal image. This is not one of mine for once. This is taken down in California somewhere. And you can see here's a black top surface, and here are even some black cars. And you remember from the last video we did, the black cars are actually really hot because the sun's absorbing, the black cars absorbing that solar radiation and turning it hot, turning it to heat. Well, the sun's been baking down on this black top all day, which means the surface of the street is being absorbed, is absorbing solar radiation and turning it into heat, Now the ground is actually hotter than if you touch this car. Now if you can imagine, this is a California hot summer day. How hot would it be just to touch this car? And if you look and see, the heat signature says that the road is much hotter than the car. Now if you're in a nice place, and this is something they're actually trying to do in California, instead of having blacktop surfaces, they're putting down concrete. Concrete is a light gray, which means it reflects more light. I'm even seeing now what they're doing is they're taking bottles and they're recycling them by melting the bottles down and mixing it with gravel and pouring kind of this plastic concrete, which is light colored, and it does not hold that heat very well. I should say convert to heat very well. So if you have a situation where you have a nice gray concrete versus a black pavement, it's going to reflect more light. It's got a higher albedo, and it's going to be a lot nicer for you to walk on. They've literally, in places like Los Angeles, they've taken to painting the streets so that the air temperatures in those areas are not as hot as it can be. So you ran into the sand. Why did you go to the sand instead of that hot surface? Well, it turns out that when the sunlight heats up the surface of the earth, it only heats up about 2 to 3 inches of earth. So if you go much further below that, the earth is not a real good conductor of heat. So it heats, and it just turns that heat back out into the atmosphere. You go down about 3 inches, you dig about 3 inches into that sand, it's actually going to be rather cool because the sun can't penetrate that surface. So why is the water so cool? This is a little bit more complicated because unlike land, water has the ability to take in even more sunlight than land and absorb it. And you can actually see that when you have a nice clear ocean or something like that. You can see the sun rays penetrating into the water, and that water is absorbing it, which means it's going to be turning it into heat. So why is water so cool? Well, it turns out the reason that water is so cool is it has the ability to mix. Now, even though light does penetrate a lot further into water than it does sand, it does still only penetrates like 6 to 10 feet, depending on the clarity of the water. Uh, what's below that stays cool. And water just doesn't stay still, it mixes around. You have waves, you have currents, you have the water's moving around, it's constantly moving around. So it's taking the heat from the surface and it's moving to the bottom and taking the cold water and kind of mixing it to the top. So it mixes and mixes and mixes. So it kind of sort of, it's a good battery. It's a good way of absorbing energy from the sun and maintaining the heat. But the temperatures don't change greatly between daytime and nighttime. So the surface of water, if it's about 60 degrees during the day Fahrenheit, it's probably going to be about 60 degrees at night Fahrenheit, because it's constantly mixing. So the water temperature doesn't change versus land. During the daytime it gets really, really hot. You might get to like 110 degrees during the day, but at nighttime it might drop down below freezing. You've probably heard before, in the desert you can die of heat exhaustion during the day because the surface of the earth is so hot it's heating up the air. But at night that land gives off all that heat and it's not hot anymore. You could actually die of hypothermia in the middle of the desert because it gets so cold. So what does this mean in terms of weather? Well, because the Earth's surface is hot, that causes the air to become less dense. And if it becomes less dense and it starts to rise, you got to remember that air is pushing down on you all the time. We call this air pressure. You've probably felt it as you've gone up into the mountains and your ears start to pop because you're under less air pressure. You might have had your ears pop from day to day. It's because the pressures don't stay the same where you're at all the time because of weather. Well, here in this case, because the air is rising, that means that the heat is becoming, the air is becoming less dense. That warm air starts to rise, which means the air is under less pressure. So we typically call that pressure low pressure. What you've done is you've created a low pressure area. Now, as that air gets higher and higher and higher, it starts to cool off. And over above the ocean, remember the ocean's cooler than what is on land. So if the ocean's cooler, that gives this air up here a place to go down. And as it starts to go down, it starts to sink, it's going to hit the surface. Now, if you're standing here above the water, you're feeling more pressure. So we're going to call that high pressure. So wherever you have high pressure, you have air, cooler air that's sinking. Wherever you have low pressure, we have warmer air that's rising. I'm going to say that again because this is important. We're going to be talking about this a lot. If you've ever listened to your meteorologist on TV, they talk about high pressure and low pressure. Low pressure means warm air rising. High pressure means cool air sinking. So what does that mean for if you're stuck somewhere in between? So the cold air here, it can't go down past the ocean. It's stuck. It's got to do something. So it starts to spread out, just like you're pouring maple syrup on top of a pancake. Above the land, the air rises, which doesn't mean all these people here on land are going to suffocate because they just lost all their air. What's going to happen is that this cool air is going to move from the high pressure to the area of low pressure and replace the air that went up. And what we get is this convection cycle right here. And if you're sitting here at the beach, we get this phenomenon called wind. Now, if you're sitting at a low pressure area, you don't really feel the air rising. When you're feeling at a high pressure, you don't really feel the air sinking. But if you're caught somewhere in between, you do feel that air moving from side to side called wind. So whenever you feel wind, probably what's happening is you're trapped somewhere between a high and low pressure. The greater the wind is the bigger the difference between the high pressure and the low pressure. It's no wonder people like to go to the beach. That's why I put that picture on at the beginning. Why do so many people go to the beach to fly their kites? Well, we have what's called differential heating. The land is getting hotter than the ocean, and because of that differential heating, you get a lot of wind. So it's very, very common to have wind at beaches. By the way, it's just the opposite at night. Because the ocean has the ability to hold all that moisture in, and the land can't do that. It gets cooler at night. So warmer air is now above the ocean, and cooler air is actually above the land. Now you're probably thinking, okay, well the sun just set, the land's not hot, or the land's still hotter. Yes, right after sunset. But if you go out into a beach, early in the morning, you're going to find out that the sand and all the land and even the blacktop areas are rather cool compared to the water. Believe it or not, the water is going to be warmer. And so the warm air is going to go up. So you might actually see clouds out in the ocean. That warm air is going to go up and cool off on the land and go back down. Which in this case, you might wake up in the morning, instead of flying your kite towards land, you might see your kite flying out towards the ocean. Depends on what time of day you fly your kite. So, what happens in places that are completely surrounded by water? This is actually kind of fascinating. If you've ever been to Disney World, here's a picture of Disney World right here. You probably had this experience. Most people go to Disney World during the summer, where it gets really, really hot during the day. And one of the things that people complain about when they go to Disney World, because Disney World is in Florida. Florida is surrounded by the Gulf of Mexico and the Atlantic Ocean. So what happens is you go to Disney World, it's a beautiful day to start off. It starts getting hotter and hotter. You can feel the land getting hotter. You keep wanting to go inside more. They got fans all over Disney World. But not only does it get hotter, it gets more humid. It gets muggier, and then you see something that probably looks like this. This is probably something that you would actually see at Disney World. There's this big old billowing cloud start to form. And then probably right around 3 to 5 o'clock, you start getting torrential downpours. Most people that I talked to that went to Disney World, particularly during the summer, said, yeah, just about every day, somewhere between 3 and 5 o'clock, it rained. We had to go inside, and that's what happens. So why does that happen? Well, it's everything that we've been talking about. If you can look at this picture right here, here's a picture of Florida. By the way, I stole every other image off of the internet except for this one right here. I could not find this picture on the internet, so this is Mr. Lee's sad sack drawing right here. This is Florida. This is the land in Florida. Over here we have the ocean, the Atlantic Ocean, and on the other side of Florida we have the Gulf of Mexico. Now what happens in Florida is that the water on a hot summer day will start off, the water is going to be cooler than the land. The land is heating up. However, the sunlight, that radiation from the sun, is still heating up the water above the ocean and the Gulf. And when that happens, it's going to cause that water to evaporate. So all these little dots is evaporated water, water vapor. And as that wind starts going from this high pressure to right here where it starts getting hot, and that should be marked as low pressure right there, as that air gets pushed in and starts to heat up, that moisture gets carried with that air into this low pressure, and it starts to get pushed away from the surface. Now Disney World is in Orlando, which is kind of sort of in the middle of Florida. So what's happening now is that that moisture gets pushed up, and as it gets further away from the surface of the earth, it starts to cool off. And as it starts to cool off, then the air can't hold that water. Something we'll talk about a little bit later. It can't hold that water anymore. And if it can't hold that water anymore, it starts to precipitate. And that precipitation comes in little bitty droplets, which make a cloud. And the cloud will just keep adding moisture until it gets bigger and bigger and bigger, and then it starts to rain. And then later on that night, that rain kind of goes away. It starts to cool off. Why? Because the sun goes down. All the clouds start to just disappear. Why? Because the surface of the earth is cooling off. And then by the time that the fireworks show happens at Disney World in late night, right before they close, it's almost like it's clear skies. And that is something that people that live in these tropical areas like Florida, Cuba, or the Philippines, or Guam, or Hawaii, um, they can almost like set their watches by the time of day that it starts to rain. In fact, if you go to a place, a tropical place like the Bahamas, all the people at the same time, all the locals will just go inside, and you'll be wondering, why is everybody going inside? And then it starts to rain. And it usually rains quite heavily. This is a satellite image taken from the 2011 hurricane season, and the reason I put this on is just a little image. I want you to watch. Here's Florida. So Disney World, just so you know, is located about right here. So this is Florida, and this is Cuba, and I believe this is Haiti. This is the Yucatan Peninsula, Guatemala. And in the tropical really region of this area. So these are areas that are all pretty much surrounded by water. And if what I'm saying is true, as I start this video, what you're going to be seeing is like every day at about the same time, massive clouds form over these areas. So watch this. And you can see, watch Florida right there, and you can see these big clouds every time, about the same time of day, start to float or over Florida. Now here we've got a tropical storm coming in. Now when we have weather systems coming in, we're going to talk about other different ways that the weather is affected. But when we talk about weather systems coming in, this kind of messes us up. This just means this is normal sunny days in these areas. So let me play that video one more time and look at Cuba right there and how all those clouds, which means it's probably raining, all those clouds form at about the same time. So that's kind of what's going on with differential heating between land and water. And really, it's not just land and water. You can have a white land mass and a dark land mass right next to each other, and you're still going to get that heating and cooling. So that's going to be it for today. Next time, we're going to look at something a little bit more broad. Instead of one small area, I want you to look at this globe for just a moment and think to yourself, this is the Amazon right here. This is a rainforest. Over here in Africa, this is called the Congo. That is also a rainforest. But just above the Congo, in these latitudes right through here, notice that through those latitudes, it's all desert. That's the Sahara Desert, the Middle East, Iran, northern India, Mongolia. And if you look in the United States, that's where the deserts of the United States are. So in these latitudes, we have nothing but rainforest. These latitudes, we have deserts, and in these latitudes up here we're back to rainforest. Why did that happen? Well, that's the next video. Why does that happen in the next video? It's an important video, so I can't wait to see get going with that. That should be coming in either late this week or early next week. Till then, love you guys all, and I hope you're staying safe. Take care.